Close your eyes for just a moment. Try to picture a single color that is 100% vibrant red and 100% bright green at the exact same time. Not a muddy brown, not a dark olive, not a messy blend. Imagine a color where pure red and pure green repel each other, remaining totally distinct yet existing in the exact same spot. This mental struggle has nothing to do with your imagination. You're experiencing a logic error that is hardwired into your biology. Some things are invisible because of a hardware limit. Our eyes simply lack the physical sensors to detect wavelengths like ultraviolet light. For a bee, this flower glows with a high-contrast bullseye, but to a human eye, that data simply doesn't exist. You possess every physical sensor required to detect a color like reddish-green. The signal only disappears because your brain's internal software actively blocks it. These are forbidden colors. They are categories of light that mathematically exist in the world around us, but are aggressively censored by our own brains. We have an incredibly advanced hardware system for capturing light. This 19th century map of the eye shows just how dense and intricate those biological connections really are. Around the time those diagrams were drawn, researchers realized we don't process color in a simple line. Instead, our software uses a system of opponent channels. Think of color vision as a seesaw, locking red against green. When you see red, those neurons fire, swinging the red side up, physically forcing green down and shutting it off. Your wiring makes perceiving both sides simultaneously impossible. The signals cancel out. This biological standoff is the reason a color like reddish-green crashes your visual processing system. Your brain cannot hold the seesaw in both positions at once. Why would nature design a brain that censors reality instead of showing you the full picture? Vision evolved to help you survive in chaotic environments. In a fast-moving, dangerous world, you need immediate answers. If your brain allowed reddish-green combinations, the world would be filled with visual noise. A red berry against a green leaf becomes a muddy, confusing blur, offering no useful information. By forcing colors to compete, your brain maximizes contrast. It uses this harsh opposition to sharpen the edges between objects, making the world easier to navigate. This is biological data compression. Your brain prioritizes critical differences over subtle nuances that don't help you survive. It deletes the impossible data to give you a clear, life-saving interface, even if that interface isn't entirely truthful. In the 1980s, researchers found a physical loophole to bypass this internal sensor and trick the brain into seeing the impossible. Using eye tracking technology, they projected a stripe of red and a stripe of green directly next to each other onto a subject's retina. The tracking machine moved in perfect sync with the subject's tiny natural eye twitches. This kept the border between the two colors locked on the exact same spot on the eye, never allowing them to blur or mix. Because the border never moved, the neurons responsible for detecting that edge became exhausted. They experienced neural adaptation and simply stopped firing. With the seesaw mechanism broken, the brain's software failed. Subjects reported seeing a shimmering, unnamed color that was simultaneously fully red and fully green, a hue that doesn't exist in our normal reality. This discovery shows that your daily perception of the world is a heavily edited interface. You can find other glitches in this software yourself. Look up the Stygian blue illusion to see if you can experience a self-luminous black. Your own brain defines the limits of your reality, deciding which parts of the physical universe are safe enough for you to see.